We integrate using integration by parts. You remember the formula for integration by parts is that it is some integral of some term u times some different term dv. So the parts methods say that this becomes u times v minus the integral of v du. So we have to decide here what will we let be u and what will we determine to be dv. So one we want to be able to take the derivative of, and the other we want to be able to integrate. And so it doesn't matter which one you choose for this particular problem. One method, if you choose the combination of u dv, it's easier, and the other method is a little bit longer. So let u equal to, I choose the natural log of the absolute value of t plus 8, and so thus dv would have to be that t and then the dt. If I pick u equal to t and dv equal to the natural log, you can still work that, but with that method you would have to use integration by parts recursively. You have to use it about two times, maybe even 3 times. So this may be the easiest. Either way you get the same answer. One, you just take a little bit longer. So this implies that du, the derivative of the natural log, is 1 over the term. The term here is t plus 8 times the derivative of t plus 8, which is just 1. And v is equal to, we integrate the t dt, and it just gives us 1/2 t squared. And so then we want to be able to write this integral of t times the natural log of the absolute value of t plus 8. I'm just accustomed to writing the absolute value. There has to be uv, excuse me, minus the integral of v du. So uv here for us would be 1/2 t squared times the natural log of the absolute value of t plus 8 minus v du. So this is minus, I'm going to take that 1/2 and just put it on the outside, minus the integral of v du, excuse me. So this is t squared all over t plus 8 dt. Now on this term, when we have an integral and it's improper, it's an improper fraction, this implies that you want to divide. So I'm going to keep that in blue. And so here I'm going to come over and I'm going to divide t plus 8 into t squared. Well, that's t, here this is t squared plus 8t. Draw our line and subtract. And so our remainder here is just 8t. And so what I have for that term is t plus, or minus, that is, it's minus there, 8t over t plus 8. Well, that becomes the simplification of this term, but notice again, this fraction is improper. So that implies we have to divide again. So I divide t plus 8 into 8t. That goes, t goes in 8t 8 times. 8 times t is 8t. 8 times 8 is plus 64. Draw a line and then we subtract. So this becomes minus. Excuse me. So this gives us here a remainder of negative 64. So we simplify that, and remember this part is 8 minus 64. That's a 4 all over t plus 8. So this term that we started out with was the integral of t squared over t plus 8. So that's equal to this t, right? Then minus this fraction, but that fraction is parentheses 8 minus 64 over t plus 8. So this is 8, t minus 8 plus 64 over t plus 8. So I'm going to replace what I have in blue, so then we'll integrate that term. Okay. So let's put that on the second page, and then I'm going to have to come back just to remember because I can't keep all that in my head. So what I have, we're integrating t times the natural log of the absolute value of t plus 8 dt. We said that that guy is 1/2 t squared times that natural log, 1/2 t squared times the natural log of t plus 8, and it was minus, right here, it's minus 1/2 times that integral. So it's minus 1/2 times the integral of what? What we simplified in blue. And that's this guy right here. So we write that t minus 8 plus 64 over t plus 8. T minus 8 minus 64 over t plus 8 dt. Let me go back just to make sure I got my signs right. T minus 8 plus 64. I think I wrote minus, so plus 64 over 8. Good. So this integral that we're looking for is 1/2 t squared times the natural log of t plus 8 minus, here I'm going to run, let's go ahead and just integrate. So this is 1/2 times of the integration of all those terms. So integration of t is t squared over 2, a lazy 2. And then we integrate that minus 8, so that's minus 8t. Then plus 64 times the natural log of the absolute value of t plus 8. Close that up, plus c. So what we're looking for is the integral of t times the natural log of the absolute value of t plus 8 dt. That's 1/2 t squared, the natural log of the absolute value of t plus 8. Simplify all this. This is minus 1/4 t squared plus 4t minus 32 times the natural log of the absolute value of t plus 8 plus c. I'm just going to say equal here. So this is equal to, now this natural log of t squared plus 8 is common with this natural log of not t squared, but natural log of t plus 8. So I'm going to just combine the coefficients, which is a 1/2 t squared minus 32 in parentheses times the natural log of the absolute value of t plus 8 minus 1/4 t squared plus 4t plus c. And as the old deacon down in South Alabama used to say, and that's all to it. Well, thank you.